For the purposes of this demo, please imagine that I'm an operations manager in a European auto company. We're going to launch a new line of autonomous vehicles shortly, and our team of solution architects has been working on an application to monitor these connected cars. As you see on the screen, we have a few hundred connected cars being monitored already in Europe. Let's deep dive into one of the cars to see what type and volume of data we're collecting. As you can see on the screen, we're collecting hundreds of gigabytes of sensor data every day. Now, to support a scenario like autonomous driving, the data processing engine inside the car needs to support two things. First, it needs to be edge optimized to run really well on the intelligent control unit of the car. And second, it needs to be powerful enough to support real-time decision-making right inside the car. Azure SQL Database Edge is the perfect fit for this scenario. It supports native scoring right inside the relational database to enable real-time decisions. It can handle tens of thousands of events per second. It shares the same relational engine as the SQL Server that you know and love, enabling a level of consistency for the developers across the intelligent cloud and the intelligent edge that is unparalleled in the industry. And best of all, Azure SQL Database Edge, a fully functional, performant relational database, now can run really well on ARM devices like the one I'm holding on my hand. We're also streaming a small subset of the process data in every car to a relational database in the cloud to generate operational insights on every car and across the entire fleet. Let's take a look at a dashboard that captures the key performance KPIs of this relational database in the cloud. As you can tell, we are currently running this application against AWS RDS for SQL Server. More and more cars are coming online in our simulation, and the volume of data being ingested is growing rapidly. As the database grows, it's become very clear that we've reached the limits with the current design, which cannot handle data volumes greater than 16 terabytes. As we've reached these limits, all the write transactions, all the updates to the database fail, which essentially means we cannot add any more cars to the fleet being monitored. This is a very common challenge with all relational databases. Managing very large relational databases is a complex challenge, and more often than not, developers are left with no choice but to completely rewrite and re-architect their application with concepts like application-level database sharding, which are very complex to get right. The reality is there is a very clear need for a relational database that can break through all these limits. Do you guys think we have such a database in Azure? Yes, we absolutely do with Azure SQL Database Hyperscale. Now, let's take a look. I also have the same application running against Hyperscale. Let's see how that performs. As you can tell, we're very easily able to go past the 16 terabyte limit. Both the read and write performance of the application workloads are doing great, and the database is healthy. Well, we're currently monitoring just 1,000 cars. What if we wanted to monitor 1 million? Can Azure SQL Database Hyperscale handle that? Let's take a look. This is the part of the demo I start feeling a little nervous, by the way. We're going from 1,000 cars to 1 million. Let's see if that works. Well, 1 million cars is not a problem for Azure SQL Database Hyperscale. As you can tell, the number of cars are rapidly getting added to the fleet being monitored. The read and the write performance is looking healthy. Now, of course, it's going to take a while before all the million cars get to a steady state of data ingestion. Now, in the interest of time, we actually ran this demo earlier against a different hyperscale relational database and got it to a steady state. Any guesses on how large a relational database backed by hyperscale in Azure is when it gets data being ingested from 1 million cars? Let's take a look. It's a little over 200 terabytes. That's 200 terabytes in a single relational database backed by hyperscale in Azure. Now, you may be wondering, what's the magic behind hyperscale? There are 3 key pieces of innovation that we've worked on for the last several years. The first one is where we've completely re-architected the core database engine to separate out the query processing layer, compute layer, from the storage management layer to be totally cloud native so that each layer can be scaled out independently. Now, this is an extremely hard challenge to get right for relational databases that support high-performant operational workloads. Second, we built out an intelligent caching hierarchy to leverage the memory hierarchy and SSDs in a very efficient way to get you the best price performance for workloads of any size and scale. And finally, we have technology now that guarantees that databases of any size, scale, and state can recover in constant time. We made all these groundbreaking changes while maintaining complete compatibility with the SQL Server ecosystem that has served our customers well for the last 25+ years. Now, some of you may be wondering, what about core database operations like backup and restore on these very large databases? Well, backup is a managed service. We utilize snapshots. It's instantaneous and almost has zero impact on the I/O bandwidth. But what about restores? How long does it take to restore such a large database backed by hyperscale? Well, my friends, it doesn't take weeks. It doesn't take days. It doesn't even take hours, as you may be used to while managing these large databases on-prem. With the hyperscale architecture, it takes less than 10 minutes. Now, finally, we'd like to provide personalized insights to all our millions of users of these autonomous vehicles. Now, you can imagine the amount of query processing power you'd need to actually get that to scale on a relational database. Let's see if Azure SQL Database Hyperscale can handle that. Now, what you're seeing on the screen is the Azure portal experience, which allows me to create 30 replicas on a single relational database backed by hyperscale. To put that in perspective, that's 2,400 cores of processing power on a single relational database backed by hyperscale. With that amount of computing power in a single relational database, you can easily satisfy the scenario to give out personalized recommendations to all the millions of users. Azure is the only public cloud that supports scaling SQL relational workloads at this scale and magnitude. Our customers can build their solutions on Azure with confidence that we'll be able to meet their needs today and in the future. We can't wait to see what kind of innovation you build on the Azure Data Platform.